This is RD Sharma solution. MCQ we are taking for chapter 3 binary operations. The first one is, if A star B equals A squared plus B squared, then the value of 4 star 5 star 3. Now this question and the fifth question are exactly same. So we are doing this 4 star 5 star 3. So 4 5 star is A square plus B square. So 4 square plus 5 square. In place of A you will put 4. In place of B you will put 5. So 4 square plus 5 square. First we'll do this. 4 4s are 16. And then we have 5 5s are 25. So 16 plus 25. That will be the first value. Then you have to operate this with the another value which is 3. So this is 16 plus 25. Okay, that will be 41. So 25 plus 16 is 41. Now this 4 star 5 is 41 now. So we have to operate 41 with 3. So that will be again A squared plus B squared. That is 41 square plus 3 square. 3 square. So the answer is C. Please remember this one and fifth question are exactly similar in my addition. Question number 2. If A star B denote the bigger among A and B, and A dot B is also given. A dot B is equal to A star B plus 3. Then we have to find out 4.7. So this will be, see, 4.7. A dot B is what? A dot B equals A star B plus 3. So 4.7 will be 4 star, there is 4 operation with 7. And then we add 3. But what is the operation? It is clear given that A star B denote the bigger among A and B. So which one is bigger, 4 and 7? 7 is the bigger one. So just write 7 here. And then add it with 3. So what do you get? You get 10. This is C. Question number 3. On the power set P of a non-empty set A, we define an operation, this triangle, by X triangle Y equals. So we have to understand that this question is more related to set theory. Set theory. So all these operations, all these commutativity and associativity and the identity, all these are being asked here one by one. Commutative, associative, not commutative, not associative, not identity. All these options are there. So we'll do one by one. First we'll do with the commutative part, then the associative part, and then the identity part. So what is the expression? Let me write it here. X triangle Y is equal to X bar. That is the complement. That is all the value which are not there in X. This is X complement. For example, complement of 1 is 0. 0 complement is 1, like that. So X complement intersection Y, or X bar intersection Y union X intersection Y bar. Okay. So we have to write X triangle Y, and if it is equal to Y triangle X, that is, if X and Y operated and Y and X operated, if they are similar, then we can say that it is commutative. That is A star B, if it is equal to B star A, then it is commutative. So what is Y star or Y triangle X? Just replace X by Y. So Y bar intersection X union. Now just put X as Y and Y as X. So Y intersection X bar. Now you see the first term and the first term is equal to the second term in this second line. The second term in the first line is equal to the first term in the second line. Okay. Just we need to rearrange them. The second part, if we rearrange them, it will be exactly similar to the first one. That is, this is Y intersection X bar. I am shifting it. And I can shift X bar and Y also, because X bar intersection Y is equal to Y intersection X. I am saying A intersection B and B intersection A. It's almost similar. B intersection C, C intersection B is equal. They won't change. So you can just change the position. That is why I change the position of X complement and Y. Okay. Now this also I've changed x intersection y bar. You can always write that. And in between you have union already. So A union B is equal to B union A. So what do we get is just by some rearrangement, the first one is exactly similar to the second one, right? So that is why this is commutative, yes. Now coming to the associative part, commutative we have already done. So X triangle Y, you have to introduce Z also. So X triangle Y triangle Z, if it is equal to X triangle Y triangle Z, first we operate X and Y, then we operate Y and Z. Now if I start writing it, because it is a bigger expression, it will not be feasible or advisable to do it right there. Better is to make, because this is a set, power set P of non-empty set A. If I make X and Y as these two sets, so X complement intersection Y is what? That is, whichever thing is not in X, just intersect it with Y, so this will be the area. Now whichever thing is not in Y, intersect it with X. What do you get? X and Y. So X and Y and X, when you intersect, this is the result. So from this commutative also you can show. This is commutative. Okay. Now same logic, same reasoning we are going to use it to prove that it is associative. This is X, this is Y, and this one is Z. So X, Y, Z. You can take any of them as X, Y, Z. Now X and Y, just see the left area. That is the left figure which I just made. So the interlinking or the intersection part will not be taken. But when we intersect it with Y, say X and Z we have taken, and when we intersect it with Y, the intersection part will not be taken. So only this particular part which is inside, which I am saying, the intersection of all these three will be taken. So you take in any order. X, Y operated with. First you operate X, Y, then operate with Z. First you operate Y and Z, then operate with X. Or first you take X and Z, then operate with Y. Every time this commutative part will come, center part will always be there. Right? So coming to now identity. Identity exists. Why? Because every power set has phi always inside it. Phi is null. That is this null phi. Okay. It is not empty, because a set with phi will always have something which is null. So A star E, if at all we get A back, then we say that E is our identity element, and that is what we have to find out. If at all we take this set A, or you can say an element of A, and we operate it with this phi, or phi we operated with A, and if we get A back, then that value will be, that phi will be a null set or null value or an identity value. So let us just prove that phi is a null value or not. If I write A operation Q, I will have to write X bar intersection Y union X intersection Y bar. Then in place of X write A, in place of Y just write phi. So anything intersection with phi will always be phi. And anything, any set, the phi null, phi is nothing, and if you take the complement, it is nothing but everything. And when you intersect it with A set, A will come. So A will come here. So phi union A, if you take the union, A will come. Okay. So this A is coming. So when we operate A with phi, A is coming back. That is why phi is our identity. And the answer is associative, commutative, and identity. D. Next is, if the binary operation star on Z is defined by A star B equals A squared minus B squared plus AB plus 4. A square minus B square plus AB plus 4. So we have to find out 2 star 3 star 4. The 2 star 3 first will do 2 square minus 3 square plus 2 into 3 plus 4. This is 4 minus 9 plus 6 plus 4. So you have this 10, 14 minus 9, which is going to be 5. Now 2 star 3 is 5. We will operate 5 with 4 now. 5 star 4. So in place of A, take 5. In place of B, take 4. So 5 square minus 4 square plus 5 into 4 plus 4. This is 25 minus 16 plus 20 plus 4. And the final value will be 33. Next is, if A star B equals A square plus B square, then the value of 4 star 5 n star 3. Now in my addition, the first question and fifth question are exactly similar. Okay, so I'm going to skip this question, but let me reiterate that the part C is the answer. The C option is the correct answer. It is similar to the first one. Just refer to that question. Sixth is, if a binary operation star is defined on the set Z of integer as A star B equals 3A minus B, then the value of 2 star 3 star 4 is. First we'll do 2 star 3. What is A star B? 3A minus B. So in place of A put 2, in place of B put 3. So 2 star 3 is 3 into 2 minus 3. So 6 minus 3 is 3. This is 3. Now 3 star 4 again, in place of A put 3, in place of B put 4. So 3 into 3 minus 4, 9 minus 4 is 5. Now seventh one, Q plus. This is denoting the set of all positive rational numbers. There will be no negative P by Q form. If the binary operation A O minus, I don't know what it is written on Q plus, is defined as, now we are interested in operation this, A operation B is equal to AB by 2. So we have to find out the inverse of 3 inverse. In order to find out the inverse, first we have to find out the identity element. What is the identity element? When you operate any value A with that identity element, A should come back. So I'm just using star for it, okay? It is same star and this symbol. So A star E is equal to A. What is A star E? It is AB by 2. So A into E by 2, right? So A into E by 2, what do you get? The E identity element as 2. Now we have to find out the inverse. So what do we operate with 3 so that we get 2? Okay. So A star B is equal to E. B is the inverse of A because we are getting the identity element. So 3 star B is equal to 2. So 3 star B is what? It is 3 into B by 2. I'll just change it. It is 3 into B by 2 and then it is equal to 2. I'll just change it because A star B or A operation B is AB by 2. It is 3B by 2. So 2 to the 4 and divided by 3. So B is 4 by 3 is the inverse of 3. Question number 8. If G is the set of all matrices of the form X, 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 all the elements are same, where X belongs to R minus 0. So you have to take the real number, but you cannot take 0. Then the identity element with respect to the multiplication of matrices as binary operation is. Okay. So identity element we have to find out. Identity element is when you operate this, what is given with any element that should also belong to this set, the same element should come back. So we'll apply this identity element. We normally write it with E. So E. Why we are writing for E? Because it is also belonging to that same matrix form. So the first row and the first column, X into E plus X into E. So this, you see, if I take the first row with first row with second column, is going to give me the same result. Same with the second row with the first column, second row with the second column. Same value we are going to get every time X into E plus X into E. That is 2xe or 2ex you can say. So 2xe, here also 2xe, here also 2xe, here also 2xe, and this you equate with xxxx, xxxx. Now just equate them. 2xe equate with x. So what do you get? 2xe equals x. So here E is equal to x gets cancelled. E is 1 by 2. This 1 by 2 is not 0. So what will be the final result? The final result is option C, which is just replace x by half. Half and half. 1 by 2, 1 by 2, 1 by 2, 1 by 2. So C is the correct answer. This is the answer. Question number 9. Q plus is the set of all positive rational numbers with the binary operation star defined by A star B equals AB by 2 for all A and B belongs to Q plus. The inverse of an element A belonging to Q plus. Basically, we have to find out the identity element. Because the operation is given as A star B is equal to A multiplied by B by 2. Okay. So, for identity element, if you multiply or operate A with E, it should give you A. Now, what is A star E? It is AB by 2. So, AE by 2. In place of B, just put E. So, E, what do you get? E equals 2. Now, we have to find out the inverse of A. So, A operated with certain value, which is the inverse. Let us call it as B. It should give you the identity element, which is 2. So, AB by 2 is 2. B, basically B is the inverse of A. What will be B? It will be 4 by A. The answer is D. Question number 10 here. If the binary operation is defined on the set Q plus of all positive rational numbers by, how it is defined? A operation B is equal to AB by 4. Then you have to find out 3 operation, 1 by 5 operation, 1 by 2, 1 by 5 and 1 by 2 is what we have to do first. I'll use this star for the operation, okay. So A star B is given by B by 4, 3 star 1 by 5 star 1 by 2, 1 by 5 and 1 by 2 we have to operate. What do you get? It is AB by 4. So 1 by 5 into 1 by 2 divided by 4. This get 1 by 5 to the 10, 10 into 4 is 40. So 1 by 40 is the result of 1 by 5 operated with 1 by 2. Now we have to operate 3 with 1 by 40. So 3 operated with 1 by 40 divided by 4. So 4 for 16. This goes down. 3 by 160. This is A is the correct answer. Question number 11. Let's start with the binary operation defined on set Q minus 1. That is, you cannot take 1. By the rule A star B equals A plus B minus AB, then the identity element for star is, okay. So in place of A star E is equal to A, that is what, because the identity element we have to find out, just put A as A, B as E, and this has to be equal to A. A gets cancelled, you can take E common here, and when you take E common, it will be 1 by 1 minus A inside. That is, if you take A on the right hand side, A minus A will be 0. E minus AE equals 0. Now you take E as common, 1 minus A equals 0. So this gives you two conditions, either E is 0 or 1 minus A is equal to 0. But if you take the second condition, 1 minus A equals 0, that is A equals 1. But it is not possible. So E has to be 0. So identity element is 0. Question number 12. Which of the following is true? Star defined by A star B, A plus B by 2 is binary operation on Z. Then second part is binary operation on Q. All binary commutative operation are associative. Subtraction is a binary operation on N. So there is no similarity or some interconnection between all these four parts. They are entirely different. Though first and second part are somewhat related. So we have to take one by one. First one is Z, 1Z. Z is what? Integer. So it is said that star defined by A star B is A plus B by 2. This is a binary operation on Z. A star B is A plus B by 2. Okay. A is coming from Z, B is coming from Z. A plus B by 2. This is a binary operation on Z. Z will be what? Z is actually the integer. So we have, this is the set. Now rather than proving it, let us take some value. Take A as 1, B as 2. What do we get? A plus B by 2 is 1 plus 2 by 2, that is 3 by 2. And this 3 by 2 is not belonging to this Z. It is not belonging to this Z. So this is false. First one is false. 3 by 2 is not an integer. So we'll take 1 by 1. I am saying 1 by 1. Right? Now in the second part, what we see, star defined by A star B is A plus B by 2 is a binary operation on Q. While doing this, we came to know that the value is coming as 3 by 2. So why not to take A and B again, 1 and 2, because 1 by 1 is also in Q, 2 by 1 is also in Q, so 1, 2 you can take and you can just say 3 by 2 is belonging to a rational number, so this is true. Or rather, you can take any other number like 3 by 2 or 5 by 2 and you just add them, you'll get some 7 by 6. And that is also a part of Q. That is the rational number. So the second part is true. A is false, B is true. Now coming to the third part. All binary commutative operations are associative. So for this, we will use an example that we have already done in our exercise number 1 and 2. That is, all binary commutative operations are associative. That is, a binary operation which is commutative is also associative. This we have to prove or unprove. So we'll take a binary operation and we'll just call it as 2 raise AB. Okay. Now 2 raise AB, B star A is what? A star B, B star A, if they are equal, that means it is commutative. So 2 raise AB is A star B, B star A is 2 raise BA. They are almost similar because A into B is B into A. So this is commutative. But if it is commutative, whether it is associative or not, that we have to see. So A star B star C and A star B star C, let us equate. Then we'll do first AB and then we'll do BC first. So AB is 2 raise AB and star C. Now you take 2 and all these two take to the power. That is 2 raise AB into C. Right? Here what we do? B and C has to be taken to the power of 2. So 2 raise BC. Now we have to take A and 2 raise BC to the power of 2. When you do this, 2 raise A dot 2 raise BC. Are they two similar? No, they are not similar. Okay, coming to the final part, which is the D part. Subtraction is a binary operation on n. N is a natural number. A natural number is what? You can count. 0 is not involved. The natural number is 1, 2, 3, 4 and it goes up to infinity. So subtraction is a binary operation. Let us check whether it is or not. Or just take an example. Rather, I'll take 2 and 4 and 4 and 2. So when we take 2 and 4, I'm saying subtraction is a binary operation. So operation is negative. Subtraction. So 2 minus 4 and 4 minus 2. 2 minus 4 is negative 2. 4 minus 2 is positive 2. Positive 2 is belonging to a natural number. But negative 2 is not belonging to the natural number. That is why the subtraction is not a binary operation on a natural number. Hence, this D part is false. So, which of the following is true? Only the second part, B, is true. Rest all are false. Next is the binary operation star defined on N by how it is defined? A star B equals A plus B plus AB, where A, B are natural number. So, we have to show whether it is commutative, associative, not, or both. So let us do B star A, because just replace A by B. So B plus A equals AB. BA is AB and A plus B can be written as B plus A, or B plus A can be written as A plus B. So it is commutative. Now coming to associative. Let us see associative. So A star B star C, whether it is equal to A star B star C, if we do AB first or BC first. So A star B is A plus B plus AB. Then we do it with C. So what do we do? In place of A, put all these. In place of B, put C. So A plus B plus AB plus C plus multiply both of these. So just multiply A plus C into A plus B plus AB. Okay. So A plus B plus AB plus C plus AC plus BC plus ABC. Okay. Now I'll do the second one and just see will match later. The next one is B and C. First we'll do. B and C will be B plus C plus BC. That is B plus C plus BC. I'm replacing A with B and this B with C. Now operate A with this. A plus B plus C plus BC and multiply A with all these. A with B plus C plus BC. Okay. So A plus B plus C plus BC plus AB plus AC plus ABC. Now A is there, B is also there, C is there, AB is also there, AC, BC and ABC. So they both are same. So it is associative also. So the answer is C, commutative and associative both. If a binary operation star is defined by, This is defined as a square plus b square plus ab plus 1. Then 2 star 3 star 2. So 2 star 3 in place of a we will put what? I'm just writing it directly. In place of a I'll replace 2, b with 3. 2 square plus 3 square plus 2 into 3 plus 1. So it is 4 plus 9 plus 6 plus 1, that is going to be 20. Now in place of 2 star 3 it's 20. Now we'll operate this with 2. So 20 square plus 2 square plus 20 into 2 is 40 plus 1. Let us compute it. It will be 445. D is the answer. Next is, let star be a binary operation on R defined by a star b equals ab plus 1. A star b is equal to ab plus 1. Then star is, let us see both of these, that is commutative associative. So a star b is ab plus 1, b star a will be ba plus 1, and ab and ba are same if they are multiplied. So it is commutative, associative. So we operate a with b with c. Same thing here, a star b star c. First we do ab, then we will do bc. So a star b, that is ab plus 1. So just write ab plus 1 star c. So ab plus 1. So this into this plus 1. C into ab plus 1 plus 1. What do we get? abc plus c plus 1. Now coming to the second one. So I'm just changing the color so that you know that we are doing bc first. So bc will be b into c plus 1. We will operate with a. So a into bc plus 1 plus 1. So abc plus a plus 1. ABC is there, 1 is there, but C and A are different. That is, this is not associative. So what is the answer? It is commutative but not associative. A is the correct answer. Subtraction of integers is subtraction. So we have done already a question, a part here. That is, if you see question number 12, the part D. So we did the subtraction is a binary operation on natural number already. But here the question is asking about integers, not the natural number. So if you are actually preparing for engineering and competitive exams, then this integer, natural number, this plays a vital role in formulation of question. So a equals 1, b equals 2, I am taking integer, whether it is commutative or not, and this is on subtraction, so you don't have to use star, just use negative or a minus b and b minus c, whether they are equal or not. 1 minus 2, 2 minus 2, one is negative 1, one is 1, so they are not equal. So it is not commutative. And in place of associative, let us take a, 1, b, 2, c, 3. You can take any number. This is just for explanation. So this will be a minus b minus c. First we'll do this one. We'll do a minus b first and then subtract it with c. A 1 minus 2 minus 3. There we have 1 minus 2 minus 3. So 1 minus 2 minus 3 is negative 1 and 1. 1 plus 1 is 2. Here on negative 1, negative 3. So you have minus 1 minus 3 is minus 4. So they both are not equal. It is neither commutative nor associative. So integer, natural number, as I said, this plays a very important role because the question answer will become different. The law a plus b equals b plus a is called. So a plus b equals b plus a, that is, this is commutative on addition. When we did a star b equals b star a, that means it is commutative. Where star is plus, so it is commutative. C is the answer. An operation star is defined on the set Z of non-zero integers by a star b equals a by b. For all a and b belongs to Z, then the property satisfied is. So I am talking about Z. We will be taking Z. So you can take example. Okay, but we have to check for closure also. So when we operate, the result should belong to Z. That is, whether it is a binary operation, a and b operated, a and b are in integers, a by b should also be an integer. So just take any random a and b from integers and then you see whether that result is going to come in Z or not. That is, if you take A equals 2 and B equals 1 and B 2, A star B is defined by A by B. 1 by 2, 1 by 2 is 0.5, which is not in Z. It is not closure, not following closure property. Commutative, A star B equals B star A. A by B is equal to B by A. No, it cannot happen. That is, example take 1 and 2 and 2 and 1. So 1 by 2 and this is 2. 1 by 2 is not equal to 2. It is not commutative. Then we come to associative. What does it mean, associative? A star B star C 1. I'm just taking directly the value A1, B2, C3 I'm taking. You can take any value. 1 star 2 star 3, whether it is equal to 1 star 2 star 3, we operate 1 and 2 first and 2 and 3 later. So 1 star 2 is 1 by 2, operate with 3. 1 star 2 divided by 3. This will be 1 by 2 and 1 by 2 divided by 3. This will be 1 by 2 by 3. So the first one will be 1 by 6, 1 by 2 into, because 2 will come in the denominator, or you can say 1 by 3 will go up. So 1 by 2 into 1 by 3 will be 1 by 6, and next one will be 3 by 2. So this is also not okay. So neither closure, not commutative, nor associative. So the answer is D. None of these. Next is on Z, operation star is defined as A star B equals A square plus B square for all A and B belong to Z. The operation star on Z is, so we have A star B equals A square plus B square, and this is we'll check all of these. Okay, so A square plus B square, just put B and A also. So either you can take value also. That is 1 and 2 is 1 square plus 2 square, and when you take 2 and 1, 2, it will be 2 square plus 1 square. So it is, first of all, it is not a first we have to show that it is a binary operation or not, because not a binary operation means you have to check for binary operation. So it is a binary operation, no problem with that. Coming to the commutative part, A and B, A square plus B square is equal to B square plus A square. This will always be true, because 1 square plus 2 square and 2 square plus 1 square is what? Same value. Coming to associative now. So this associative is, will operate A, B, C. First we'll operate pairwise, A, B, then B, C. This will be A square plus B square, and this will be C. Here A, and we have B square plus C square. Now these are two terms, separate terms, so we operate with them. A square plus B square whole square plus C square. Here we get A square plus B square plus C square whole square. Okay, they both are not equal. So it is, as I said, it is not associative, because all these options are there. It is a binary operation. It is commutative but not associative. So just C is the answer. Next is question number 20. A binary operation star Z is defined by A star B equals 3A plus B. So 3A plus B, A star B is 3A plus B. And this Z is very important. Because Z and N, if it would have been Z, the answer would have been different per se. So what is there, what is not there, let us check one by one. So A star B is 3A plus B. And when we take B star A, because A star B is already there, B star A is 3B plus A, and they are not equal. It seems, visually also, you can observe 1 and 2. If you give A as 1 and B as 2, then 3A plus B is 3 into 1 plus 2. And here we have 3 into 2 plus 1, which gives you a different answer. 1 will be 5, and this will be 3 into 2. B is 2 we have taken. So 3 into 2 plus 1, which gives you 7. 1 star 2 is not equal to 2 star 1. So it is not commutative. So when you have an option like this, not commutative, already C is the option. Associative, not commutative and associative. Because it is not associative, and that is a separate option which is being given. So you can just stop here and you can just say it is not commutative. Okay. If commutative, associative, some permutation, combination are given, then you should check. But if it is not a commutative and it is already by this we have proved it is not commutative. Let's start with the binary operation on Q plus, defined by how it is defined. A star B equals AB by 100 for all A and B belong to Q plus. So the inverse of 0.1 is, so 0.1 inverse. What we'll do, in order to find out inverse, we have to find out the identity element. So when we operate A with E, A should come back. So A star E will be what? A, we'll use this expression, A into E divided by 100, and this is equal to A. From here, what do you get? This will be E equals 100 because A gets cancelled. Now already identity element we have found out, E or I you can call it. Now in inverse, if we operate A with B and we get the identity element, B will be the inverse of A. So if we operate 0.1, A is 0.1, so let me write directly this one. So 0.1, if we operate it with some X or B, we should get an E identity element, that is 100. Then you can say this is 100. Then B is the inverse, so B will be 100 into 100 and divided by 0.1. This is 1 by 10, 10 goes up. So I'm just writing 10 above. This will be equal to 10 to the power 5. So this is B. So 10 to the power 5 is the inverse of 0.1. Okay. Next is, let's start with the binary operation on n natural number defined by, how is it defined? A star B equals A plus B plus 10 for all A and B belongs to the natural number. The identity element for star in n is, so identity element will be what? When we operate A with that identity element, we should get back this A again. That is the identity element. Okay. A star E, replace B by E here. So A plus E plus 10 equals A. Now from this expression, A gets cancelled, and if you take 10 on the right hand side, you get E equals negative 10. Now, the thing is that this set is a natural number. And you know, natural number are counting numbers. We don't have a negative here. It's 0, 1. Even 0 is not there in natural number. So negative 10, E equals negative 10, because identity should belong to that set. But for this operation in natural number, it is non-existent. There is no identity. Consider the binary operation star defined on Q minus 1. By the rule, Q minus 1, that is rational number without a 1. By the rule A star B equals A plus B minus AB for all A and B belong to Q minus 1. The identity element in Q minus 1 is, so we have to check the identity element all without 1. So right, getting the logic from the previous question, A star E equals A should come. So just put B as E, A plus E minus A is equal to A becomes cancelled. You can take E common, 1 minus A equals 0. So from here E is equal to 0. A is equal to 1, which is not possible because 1 is not there in Q. So E is equal to 0 is the answer. This is the identity element in Q minus 1 with respect to star 0. So the option here is, the first option will be the correct answer. For the binary operation star defined on R minus 1 by the rule. What is the rule? There is all real numbers except 1. A star B is equal to A plus B plus AB for all A and B belonging to R minus 1. The inverse of A is, so for inverse you need identity element. Let us see the identity element. If we operate A with that identity element, A should come. So A star E will be A plus E plus AE equals A. So same as the previous question, E is 0. Okay. And since E is 0, we can use this identity element to find out the inverse. A star B equals identity element B is the inverse of A. What is A star B? A plus B plus AB. And what is E? Is 0. So A plus B plus AB is equal to 0. So now B is the inverse. So have B on left hand side and take everything on the right hand side. So whatever is in the right hand side will be the inverse. So B plus AB equals negative A. Then B 1 plus A, I'm taking B common, equal to negative A. B equals negative A by 1 plus A. and this is the result. B is the answer. For the multiplication of matrices, binary operation on the set of all matrices of the form A minus B, B, A, the inverse of a value is given. So let me write this. This is the form. So we have to find out the inverse of this matrix. The inverse is, whenever we find out the inverse, we say that A star B equals identity element E. So B is the inverse of A. Same logic we are going to apply here. So this is 2, 3, negative 3 and 2. The inverse of this will be when it is multiplied by certain matrix, we should get the identity element. So whatever is given in the form A, B minus B, A, just write that. Don't worry about M or N or any other X, Y like that. So just write this because this is the form. And this form is taken by A or B, either of them. We have this identity element as the result. Now the first row and the first column, 2 into A plus 3 into minus B, that is minus 3B. Then first row and the second column, 2 into B and plus 3 into A. Then second row, first column, negative 3 into A is negative 3A. 2 into negative B is minus 2B. Then the second row and second column, so minus 3B and plus 2A. Okay, this is equal to the identity matrix. Now we can equate each element with the corresponding element on the right hand side. So first use any equation which is equal to 0, and whatever you get, put it in the equation where you get equals to 1. So negative 3A, negative 2B equals 0 I am putting. From here, either find A or B. So I am finding A here, so it will be minus 2B by 3. This is A. Now put this in any of the equation which is equating to 1. We have 2 into A, 2 into A minus 3 into B equals 1. So that is you're going to be minus 4 by 3B minus 3B equals 1. And I'm just taking negative B common. So 4 by 3 plus 3 you get. 4 by 3 plus 3 by 1 is 4 plus 9 by 9 plus 4 by 3, 13 by 3. So you get minus B, and this is 13 by 3. I'm just writing 13 by 3 in place of this. B will be equal to 3 goes up, 13 goes down, and negative on the right hand side. So B is negative 3 by 13. What will be A? A is minus 2 by 3 into B. Just put B here. What do you get? If it gets cancelled, it will be 2 by 13. Okay. So this is the final one. A and B replace here. A is 2 by 13. A is 2 by 13 and B is negative 3 by 13 here. Here minus minus becomes plus. So this is the final answer. C is the correct answer. On the set Q plus of all positive rational numbers, a binary operation star is defined by A star B equals AB by 2 for all AB belongs to Q plus. The inverse of B is, so A star B is AB by 2. Okay. So we'll find out the identity element A star E equals A. A star E is AE by 2 equals A. From here you get E equals Q. Now A star B equals E because B is the inverse of A. AB by 2 equals E is 2. Remember, B is the inverse. B is 4 by A. And we have to find out the inverse of what? The value is 8. So just replace A by 8. And 4 by 8, you can write 4 by 8 as 1 by 2 because the options here is B, the 1 by 2. Just put A as 8. B equals 4 by, this is 8, it's 1 by 2. Okay. So 1 by 2 is the inverse of 8. Let star be a binary operation defined on Q plus by the rule A star B equals AB by 3 for all A and B belongs to Q plus. The inverse of 4 star 6 we have to find out. Okay. Let us find out the identity element first. A star E equals A. So A star E in place of B just replace E. It should be AB by 3. So AE by 3 equals A. From here we get the identity element as 3. Now see it very carefully. 4 star 6 is the actual value for which we have to find out the inverse. 4 star 6 inverse is the inverse we have to find out. A and B, if we operate, we get E. B is the inverse of A. Same thing. I'm just writing it as total value inverse. And that has to be E, identity element. See, A star B is what? AB by 3. So these two multiplied by 3. So A 4 star 6 into multiplied by 4 star 6 raised negative 1 divided by 3 equals 3. So 4 star 6 inverse we have to find out. So 4 star 6 inverse will be 3 3 is 9. It's not 3, it's 9 actually. 3 into 3 is 9 divided by 4 star 6. So 4 operation 6 is again A star B is AB by 3. So 4 into 6 by 3, 3 into the 6, 4 to the 8. So you get 8 here. So this will be 9 by 8. So the answer is the first one, A. 9 by 8. Why? Because 3 was already there. Just write 9 by 8. A is the correct option. This is how you have to find out the inverse. The number of binary operations that can be defined on a set of 2 elements. So the binary operation that can be defined on a set of n elements is given by n raised to the power n squared. When we have 2 elements, it will be n equals 2. So 2 to the power 2 square it will be. But it will be 2 to the power 2 to the 4. So 4 is 16. So it is 16. The answer is 16. The number of commutative binary operations that can be defined on a set of 2 elements is. So number of commutative binary operations, the expression is what? Please see it very carefully. It will be n to the power of n minus 1 by 2. N to the power n minus 1 by 2. Since n is 2 here, the elements are 2. 2 to the power 2 into 2 minus 1 by 2. So 2 to the power 2 minus 1 by 2, 2 gets cancelled, 2 minus 1 is 1. So 2 to the power 1 is 2 only. Right? So the answer is 2 here. Let me tell you again, the formula is n to the power n raised to the power n minus 1 by 2. These are the number of commutative binary operations on a set of n elements. Okay, this is all about this exercise. Thank you so much. Take care of yourself.